Agenda. So our agenda, we're going to start off with astronomy. We're going to talk about, hey, what is astronomy? And then we're going to get into some vocab a little bit. So we're going to talk about our galaxy, and then we're going to talk about our solar system. And then what is going to be really cool, we'll talk about some of the planets. And then, hey, what's next? What next? Okay? So what is astronomy? So, Science Daily says that astronomy is the scientific study of celestial objects such as stars and planets, comets, and galaxies, and the phenomena that originate outside of Earth's atmosphere. So, astronomy is obviously us looking at the stars and understanding the stars and the galaxies and how they move and all the different phenomena that is out in space. So some vocabulary that we're going to talk about. The first term is galaxy. So galaxy is a collection of stars and planets that are held together by gravity. The next vocab term is a solar system. Now, a solar system is a group of celestial bodies that revolve around the sun. Okay, and then we have planets. There are so many different definitions for planets out there, and I'm not sure if there's one completely agreed upon definition of planets. But you have planets, you have dwarf planets, and I'll leave that for the astrophysicists to continue to posit their positions about what are and what are not planets. Orbit. An orbit is the curved path through which objects in space move around a planet or star that has gravity. Okay? And DFS. Now, I put DFS in here because on some of the diagrams that I'll show you later on, DFS stands for distance from sun. And this is primarily going to deal with the planets within our solar system. Okay? All right. And radius is obviously the distance from the center of a planet to its edge. All right. So I wanted to put this diagram up to kind of give you an idea. Now, this whole white cloudish area, that is our galaxy. That is our galaxy. That is the Milky Way galaxy. Now, where it says we are here, that is our little speck. That's our solar system. Okay? Some people might mistakenly think that our sun is that huge white ball in the middle, but that's not it. Okay? Our sun is just that little speck. Okay? And our planets rotate, or our solar system rotates within this whole Milky Way galaxy. So it kind of gives you an idea of how expansive the Milky Way galaxy is. And we've been already able to realize that there are thousands and thousands and thousands of other galaxies that are out in space. So within our solar system, getting back into our solar system, there are various types of planets. Okay, the first are terrestrial planets, and these are planets that have typical rocky structures that, just sort of like Earth. They're from rocks. Okay, and then we have gas giants, and our gas giants are made up of frozen gases. So many people say that on a gas giant, you would pretty much just fall through the planet because there's not a solid surface that you could really stand on. Okay, and then you have dwarf planets, which are just that they're very small planets. Okay, the terrestrial planets within our solar system. The first one obviously is Mercury. Mercury is the closest planet to the sun. Its radius is 1,516 miles, and its orbit, it actually takes around 88 days to get around the sun, and it is about 36 million miles away from the sun. Remember, those are some of the vocab terms we talked about in the previous slide. We talked about radius, orbit, and DFS, or distance from the sun. Now, the second planet in our solar system, this is the second closest planet, which is Venus. And the radius of Venus, as you can see, Venus is actually quite a bit larger than Mercury. Okay, so from one side of Venus to the other side of Venus, okay, the diameter, which is different, which is twice the radius, you're looking at about 7,400 miles. Now, Venus, because it is a little bit further away, it takes a little bit longer to get around the sun. So it takes about 225 Earth days to get around the sun, and it's almost twice as far away from the sun as Mercury is. Now comes our home planet of Earth. Now, Earth's radius, 3,959 miles. So Earth is about 8,000 miles across. Obviously, we know it takes about 365 days to go around go around the sun. And Earth is 92.96 million miles away from the sun. But one cool thing about Earth, we have a moon, okay? Now, Mars, which is one of the next planets, or it's actually the fourth planet in our solar system, it's a little bit smaller than Earth, 2,106 miles. Its orbit, it takes 687 days to get around the sun. So actually, it almost takes 2 Earth years for Mars to orbit the sun. Now, Mars is quite a bit further out than from Earth. Well, it's quite a bit further out from the sun than Earth is. So it's 141.6 million miles from from the sun, and it has 2 moons. Now, one cool thing, we'll start getting to some of the gas giants. When we start learning about these are so amazingly cool, how gas giants were formed. Now, again, I'm not going to go into how they were formed and all that information. I'm just here to really just put some information into your mind about the possibilities of astronomy and what's out there, okay? So, the first and largest planet in our solar system is Jupiter. Now, Jupiter's radius is 43,441 miles that we can guesstimate, okay? So, remember, the radius of Earth was just under 4,000 miles, okay? So from Earth, the whole width of Earth is 8,000 miles. The whole width from end to end of Jupiter is almost 90,000 miles. It's so much huger than Earth, okay? Now, the orbit of Jupiter, it takes 4,300 days for Jupiter, or Earth days for Jupiter to go around the sun. And Jupiter's extremely far from the sun. It's 483 million miles from the sun. Okay? Now, one cool thing about Jupiter, because Jupiter's so huge, has such a gravitational force, Jupiter has 63 moons. 63 moons, which I find amazing. Imagine standing on the surface of Jupiter and see 63 different moons orbiting you, not including all of the different other space debris and things like that are orbiting the planet. Okay? The second largest planet in our solar system is Saturn, and Saturn is the next furthest planet than Jupiter. Now, Saturn's radius is 36,184 miles. So Saturn's from side to side, Saturn is about 72,000 miles, okay? Which is, you could almost stack 10 Earths, from side to side, and it would just be getting close to Saturn's, okay? And Saturn is really far from the sun. It takes 10,000 755 days for Saturn to orbit the sun. 10,000 days, Earth days. Can you imagine that? Okay? So I can't even, that's almost 20 years. Well, that's well over 20 years that it takes Saturn to orbit the sun. So if you were born today, if a person was born today, when they turned 21, or well, when they turned around the age of 21, that's about the time that it took Saturn to orbit the sun. Okay? Saturn is also 882 million miles. 882 million miles from the sun. And Saturn also has 60 moons. 60 moons. Now, if you know this, Saturn has these cool rings that go around it. All right? Now, we believe that those rings are made up of ice and gases and just different debris that goes around the planet. You can only imagine how beautiful that is from the surface of Saturn, just to sit and just look at the different colors of those rings as they go around. And then you have Uranus, which is one of the other large gas giants in our solar system. Now, Uranus is obviously quite a bit smaller than Saturn. It's only 15,759 miles as far as the radius. The diameter, obviously, is about a little bit more than 31,000 miles. But again, look at the orbit of that. Uranus, it takes 30,687 days for Uranus to orbit the sun. All right, and it is 1.784 billion miles from the sun, but yet it still orbits the sun. Now, what's cool about Uranus is obviously it has 27 moons that orbit it. And then you have Neptune. Neptune is the last of the gas giants. Now, Neptune is just slightly smaller than Uranus, okay? So Neptune's diameter, or actually radius, is 15,229 miles, but the diameter is obviously a little bit more than 30,000 miles as well. But look at the distance, or look at the distance it is from the sun and how long it takes for it to go around, just to do one orbit. 164 years. So it's outside of the human's lifetime, that our natural lifetime that we have right now. Okay? So I just find that totally amazing. It also has 14 moons. And if you notice that 3 out of the 4 gas giants have these rings around them. Okay? Now, we talked about the terrestrial planets, and we then also talked about the gas giants or the gas planets. Now we're going to get into the dwarf planets. Now, there are a few dwarf planets in our solar system. The first is Ceres. All right, and Ceres is actually fairly close to Earth. Actually, Ceres is between Earth and Mars. There's an asteroid belt, okay, and Ceres is located within that asteroid belt, okay, and it's 294 miles. That's the radius of it. So it's about 500 miles in complete diameter. Now it takes 1,680 days for Ceres to orbit the sun, and it is 257 million miles from the sun. Okay? Then you have Pluto. Pluto used to be what was called one of the regular planets, but they decided, because of Pluto's size, they wanted to classify it as a dwarf planet. As you can see, Pluto is fairly small. Pluto is its radius is 738 miles, and its total diameter is about 1,500 miles. I mean, less than 1,500 miles. But if you look at the orbit and the Earth's, and our sun's magnetic force or gravimetric force on Pluto is still so strong that it actually still holds it in orbit. But Pluto is 3.67 billion miles away from our sun. It takes Pluto 248 Earth years to go around the sun. 248 Earth years to go around our sun. Astounding. And then Eris. Eris is one of the newer dwarf planets located. Now, Eris is located past Pluto, much further past Pluto. But what they're looking at right now is Eris is pretty much kind of like on the edge of our solar system. And what we're finding is that there are probably a lot more potentially dwarf planets and other objects located outside of the 9 dwarf planets and somewhere in the Eris area. Okay, so you see, Eris is the largest dwarf planet. Okay, its radius is 1,445 miles, and diameter is obviously about 3,000 miles. Okay, but if you look at the orbit, it takes Eris 561 years to orbit the sun, and it's 8.74 billion miles from the sun. Okay, 8.74 billion miles from the sun. So just our solar system, just our 11 planets within our solar system, there is so much opportunity. There's so much potential could possibly happen. Now, one of the things I wanted to do was I kind of wanted to give a little bit of representation of the size and scope of our solar system. Okay? So, if you look over here, you'll see our sun. Our sun is huge. Okay? And then you'll see Mercury. And then based off Mercury size, then you'll see Venus. And then you'll see Earth with our one moon. You'll see we're just a tad bit larger than Venus. Okay? And then you see Mars. And then the asteroid belt that I was telling you about earlier. Then there's Ceres. And Ceres is located within that asteroid belt between Mars and Jupiter. All right? And then you see how huge Jupiter is. Okay? Huge Jupiter is. And then you can see how you can stack so many Earths inside Jupiter. And then Saturn, which is slightly smaller than Jupiter. And then one of the things, again, you'll be able to see here is one thing I really like about this particular screenshot is that look at the size of the moons of Jupiter and Saturn. Some of them are actually large enough to be their own planets or dwarf planets. Okay? And then you'll see Uranus, Neptune, and obviously Neptune's moon, Triton. Then Pluto, and then all the way out here, you'll see Eris. Okay? So there is so much potential that we don't know about space. All right? So first and foremost, I want to say thank you to everybody who watched the video. I certainly do appreciate your support. Again, if this video was of any help to you, please subscribe. It would be a great help to continue to get STEM information out to our community and out to our various students. Again, if there are specific things that you would like me to do some research on, please feel free to email me, and I'll get back to you and provide you with some feedback and maybe create some type of video, instructional video to help you out. All right, so again, thank you for watching. Please subscribe and have a great rest of your day.